recording. Okay, go.
Who knows our rule for energy, like in physics? What's our underlying rule for energy always, no matter what? Energy is always conserved.
So fun. Okay, you have to stand back, Maxie.
Okay.
And
so,
wow, it's there.
So energy is always conserved. We can transform it from one form to another, but we can't create it and we can't destroy it. We're going to bend that rule when we come to nuclear physics because we're going to change mass into energy and we're going to change energy into mass. That's going to happen later on this term, but when we're doing collisions, we're assuming that no mass is turning into energy, no energy is turning into mass. So energy is always conserved. And so there's two different types of collisions. There are ones, in every collision, energy has to be conserved, but often when we're analysing collisions, we're thinking about kinetic energy. And kinetic energy, the energy of motion, is not always conserved. It is conserved if it's what we call an elastic collision. The other possible type of collision, who knows what are we going to call it if it's a collision in which energy is not conserved?
A bad one.
What's the opposite to elastic? Come on. Starts with I.
Impossible.
It starts with I-N.
Inert.
Inelastic.
Boring.
So almost every collision in real life, almost every collision is an inelastic collision. The only time we get elastic collisions generally is when there's a tiny mass bouncing off a big mass, and that way it's going to transfer very little momentum to the big mass, and so it's going to have almost all of its kinetic energy, and it's going to be effectively an elastic collision. Often in your exam you might get asked whether a collision is elastic or inelastic, and you do that by calculating kinetic energies. So kinetic energy is not conserved. What happens to it?
It's magic out of this universe.
What happens to the kinetic energy when it's not conserved?
It runs away. It grows like so.
It's turned into other forms of energy, like heat and potential.
Transformed into heat, sound, and work
Oh yeah, the sound of energy.
done mangling metal, that kind of thing.